Bismillahirrahmanirrahim. Assalamu alaikum. In this video, we shall study the shell method to find volume of solid of revolution. Let us explain it by some figure. This is the graph of some function f of x, and we need to rotate the region from A to B about the y-axis. Now, if we rotate this region about the y-axis from x is equal to A to x is equal to B, we get a figure like this one. Now, the area below the function of f of x about the x-axis from x is equal to A to x is equal to B can be divided into cylinders. Let us make the first cylinder. This is some part of the cylinder. I am drawing this on the next side like this one. Now from here I can make a figure like this one. Let us say this is the required solid of revolution, and we need to find volume of this solid. Now look at this cylinder. In the first case, we need the thickness. This is the thickness which is denoted by dx, and the height of the cylinder from here to here, it is denoted by h. And now we need the radius. Radius is this distance, and this radius is r of x, which is equal to x here. So the volume of the cylinder is equal to circumference of this cylinder, which is 2 pi r, height of the cylinder, which is h, and thickness of the cylinder, which is dx. And now if we integrate it from A to B, we get volume of this solid. Now, to find volume of the solid, when we rotate the graph about the y-axis, we shall use this formula. But as you can see, sometime we write it like this one. 2 pi, integration is from A to B, r of x is x, and h of x will be equal to the given function into dx. If we are given two curves, one is f of x, the other is g of x, and if we rotate this region about the y-axis, in that case, the remaining formula is same, but h of x is equal to the bigger curve minus the smaller curve. So that is f of x minus g of x. In example number 1, we use the shell method to find the volume. As we are rotating the region about the y-axis, therefore we use the shell formula. V is equal to 2 pi. Integration is from A to B, r of x into h of x dx. And let us say this is equation number 1. Now the first task is to find the point of intersection. So we equate the two curves. And from here, if we simplify, we have x squared by 9 is equal to x, which gives x squared minus 9x is equal to 0. And from here, we have x into x minus 9 is equal to 0. So we have 2 points, x is equal to 0, and the other point is x is equal to 9. Now we need to find the greater curve inside this interval. So if we put different values from inside this interval, we can find that under root x is greater than or equal to x by 9. Sorry, this is x by 3 for all x belongs to 0 comma 9. Now from here we get the height of the cylinder, which is h of x is equal to x under root minus x by 3. Let us see this by the graph. So if we draw the graph of the function y is equal to under root x, and then the graph of the function y is equal to x by 3, we have this thing. Now this is y-axis and it is the axis of rotation. So parallel to the axis of rotation, we make a cylinder, and now we need the height of this cylinder. So the height of this cylinder is the greater curve, which is under root x, minus the smaller curve, which is x by 3. And now let us use formula number 1 to find the volume. But the next thing which we need is the radius r of x. So radius r of x is equal to x. Therefore, 1 implies that v is equal to 2 pi. Limits of integration are from 0 to 9 into r of x, which is x, into h of x, which is under root x, minus x by 3 into dx. If we further simplify this, we have v is equal to 2 pi, integration is from 0 to 9, multiplying x, so x power 1 over 2 into x is x power 3 by 2, minus x into x, that is x square, divided by 3 into dx. And in the next step, now let us integrate this. So if we integrate, we have 2 pi and integration of x power 3 by 2. This is x power 3 by 2 plus 1, 3 by 2 plus 1 divided by 3 by 2 plus 1, minus x power 2 plus 1. So that is 3 divided by 3. So this is 3 into 3. The limits are from 0 to 9. And now let us simplify and put the limits. So we have 2 pi, and this is x power 5 by 2 divided by 5 by 2. So it's become 2 by 5, minus x cube divided by 9. The limits are from 0 to 9. Now we need to put the upper limits. So we have 2 pi. The limits, this is 2 by 5. The limits is 9. So 9 power 2 by 5 minus 9 power 3 divided by 9, and the remaining is minus 0, so we don't need to simplify this. So if we further simplify this, we have v is equal to 165 divided by 5 pi, and that is the required volume of the solid. Now rotating this region about the y-axis, we get a figure like this one, which is a cylinder. The height of this cylinder, which is parallel to the axis of rotation, is h, and its radius is r of x, which is equal to x. The limits are from 0 to 9. Now let us solve example 1 by the washer method. As we are rotating about the y-axis, so the washer formula is v is equal to pi. Integration is from c to d into r of y whole square minus small r of y whole square into dy. So we can see that all functions are in y. Therefore, we convert y is equal to under root x as squaring both sides. We have x is equal to y square. And from the next curve, which is y is equal to x by 3, we have x is equal to 3y. Now we need the point of intersection from these two curves. So we equate these two curves as y square is equal to 3y. From this we have y square minus 3y is equal to 0, and then we have y minus 3 is equal to 0. So we have 2 points. Y is equal to 0 and y is equal to 3. Now we need to find the greater curve inside this interval. So if we put different values, we can find that 3y is greater than or equal to y square for all values inside the interval 0 comma 3. So the bigger curve that is denoted by capital R of y, and the smaller curve that is denoted by small r of y. Therefore, putting values in 1, we have v is equal to pi, integration is from 0 to 3, r of y, capital R of y square. So we write 3y whole square minus small r of y square. So we write y square whole square into dy. And if we further simplify this, we have pi, limits are from 0 to 3, and from this we get 9y square minus y4 into dy. And now let us integrate this. So we have pi 9y cube divided by 3 minus y power 5 divided by 5, and the limits are from 0 to 3. Let us simplify this. So we have, by using the upper limits, we get pi into 3 cube minus 3 power 5 divided by 5, and as the lower limit is 0, so we don't need to use it. And from here, if we further simplify this, we have the required solution 165 divided by 5 pi, which is the same solution as obtained by the shell method. Let us see the graph. Now, this one is the graph of the function x is equal to y square, and this one is the graph of the function x is equal to 3y. If we rotate it about the y-axis, we have a graph like this one. Now, this distance from here to here, that is capital R of y. And the distance from here to here, this is small r of y. So this is the origin, and now the point, this is x is equal to 3. So rotating this total region about the y-axis, we find a cylinder, a solid like this one. You can see it. This is actually a disk. So we make a disk, and now this is solid of revolution. So we find its volume by using the washer method. In example 2, we are given a function y is equal to x square, and we are rotating the region about the y-axis to generate a solid. To use the shell method to find the volume, we have the formula v is equal to 2 pi. Integration is from a to b r of x n to h of x dx. Let us say this is 1. And now here h of x, this is the given curve which is given by x square, and r of x, that is x. Let us see by the graph of the curve. So the graph of this function is this one. This is the graph of y is equal to x square, and we are rotating the region about the y-axis, and the limits are from 0 to 1. Now to rotate this, we make a cylinder like this one. Now the height of that cylinder, that is h. So h is given. H is x square, and the distance, this one is r of x, and that is equal to x. So if we rotate it about the y-axis, we get a solid like this one. This is our cylinder. So from this we make a solid like this one. So that is the required solid, and we need to find its volume. So putting values in formula number 1, we have v is equal to 2 pi. Limits are from 0 to 1, x into x square dx. And if we simplify this, we have 0 to 1 x cube dx. Integrating, we obtain x cube plus 1, so this is x4, divided by x3 plus 1, so this is 4, and the limits are from 0 to 1. If we further simplify this, we have 1 power 4 is 1, so 1 over 4 minus 0, and from this we get v is equal to pi by 2. So that is the required volume of the given solid, which we create by rotating the curve. To solve example 2 by using the disk method, as we are rotating the region about the y-axis, so the disk formula is v is equal to pi. Integration is from c to d capital R of y square dy. Let us say this is 1. Now we need the function in y. So from y is equal to x square, we obtain x is equal to under root y. Let us say this is 2. To find the limits, if we put x is equal to 0 and 1, we get y is equal to 0. And if we put x is equal to 1 and 1, we get y is equal to 1. So the limits of y, that is from 0 to 1. Now putting values in formula number 1, we have v is equal to pi. Limits are from 0 to 1. R of y. So R of y is this function. This is R. So we have under root y whole square into dy. Let us simplify this, which gives 0 to 1 y dy. And if we integrate, we have y square by 2, limits are from 0 to 1. Let us put the limits. So we have 1 square is 1, so 1 over 2 minus 0. And from this we get v is equal to pi by 2. So we have the same solution which we obtain by the shell method. Let us see the graph of this question, in which we rotate this graph about the y-axis. So we make a disk like this one, and this is y-axis, and we are rotating here. The limits are from 0 to 1, and this is x is equal to under root y. So we need to find volume of this solid. In example number 3, we are rotating the region about the y-axis to generate a solid. Let us find its volume by using the shell method. According to the shell method, v is equal to 2 pi. Integration is from a to b r of x into h of x dx. Now here the graph of this curve is like this one. This is x-axis, this one is y-axis, and the graph of the function is like this one. So let us say this is the graph y is equal to x minus x cube. So parallel to the axis of rotation, we can find a cylinder. Now the thickness is denoted by dx, and this is the height h. So the height h here is h of x, which is equal to x minus x cube. And the distance from here to here, that is the radius r of x, which is equal to x. So putting these values in this formula, we have 2 pi. Integration is from 0 to 1. R of x is x, and h of x is x minus x cube dx. Let us integrate this. We have 2 pi. Integration is from 0 to 1. This is x square minus x power 4 dx. And from this we can find 2 pi. This is x cube divided by 3 minus x5 divided by 5. Limits are from 0 to 1. So let us put the limits. We have 2 pi, and if we put 1 cube is 1. So we have 1 over 3 minus 1 power 5 is 1. So 1 over 5 and minus 0. So let us simplify this. If we simplify this, we have 2 divided by 15. And finally, we get the volume, which is 4 pi by 15. So that is the required solution. Let us try to use the disk or washer method to solve example number 3. As we are rotating the region about the y-axis, therefore we use this formula. Now here r of y is a function of only y. So we need to write the given function as x is equal to f of y. It means that there will be a single x power 1 on the left hand side, and we shall transfer all the terms to the right hand side in such a way that there will be no x in any term on the right hand side. So let us take the given function. If we simplify, we get x is equal to y over 1 minus x square. So this is not equal to f of y. In other words, this is not equal to the function such that there will be no x on the right hand side, but there is 1 minus x square. That is why we cannot use the disk or washer method. Hence, we need to learn the shell method to solve such type of problems. That's all.